Hi guys, welcome back to our channel. Automation is future. So in this video, we are going to see about one more direction control valve, which is most commonly used for double acting cylinders. So in this, we have basically two types and different positionings. So in these two types, we have 4 by 2s and 5 by 2 walls. So in the last video, we have seen 3 by 2. The same way, we have 4 by 2 and 5 by 2. So let us see what is 4 by 2 and 5 by 2. So the very first symbol which we can see on our screen is called as 4 by 2. So as we know, as I said, this is used for double acting cylinder. Double acting cylinder has two ports for forward movement and reverse movement. Uh, we can say extension and retraction movement of the cylinder. For extension purpose, one port, and for retraction purpose, the another port. So for these controlling sending air from these two ports, we need two output ports which are nothing but on the top these 4 and 2 are connected. So here you can see these 4 and 2 are connected to our double acting cylinder, and as usual we wanted air supply source, that is our one port, and for air escaping purpose we have another port number 3. Okay, the same way there was invention of a 5 by 2 with an extra port which is nothing but extra exhaust port or extra release port number 5. So what has happened means, while working with 4 by 2s in pneumatics, okay, while working with 4 by 2s in pneumatics, whenever there is faster reciprocating movement, the air needs to escape from the single outlet port or single exhaust port, which is nothing but 3. So sometimes it used to get airlocked. To avoid such airlocking, there was design of 5 by 2. So nowadays we can say 4 by 2s are not much used in pneumatics, but in hydraulics we will be using 4 by 2s only. Why? Because in hydraulics we would be connecting the flow of liquid back, and that liquid is refiltered and used back. So for that purpose only we will be using this single port drain or single port exhaust valve for hydraulics. But in pneumatics we will be releasing air into atmosphere, so air needs to move faster ways to the outward. So for that reason we will be using 5 by 2s, and depending upon the type of application we will be going for 4 by 3 or 5 by 3. In that we have different types. So here we have 5 by 2 with pilot operated. So here you can see we had a table called port description table. So this table, whatever the table we can see, this we call as port description table. So in this port descriptions table we can see there are two standards: ISO standard 1219 and ISO standard 5599. So initially, before 2011, these both standards are being used by both pneumatics and hydraulics. But just for our convenience purpose, ISO 5599 is being used for pneumatics, and ISO 1219 is being used for hydraulics. So here you can see uh, power connection, whatever the air source or liquid source, whatever the source of supply, we will be denoting it as number 1 or P, and all the even numbers 2, 4, 6, 8 under 10, these all are given for outlet ports or working ports where we would be connecting to our cylinders. Okay, all the negative numbers 3, 5, 7 and 9, these are given for like exhaust ports or drain ports where we will be releasing the air. And about 10 we had given even numbers, we are given for pilots. Pilot in the sense we will be using air pressure for signaling purpose only. So till now we had seen a mechanical or manual. The same way we'll be using air pressure for applying the force. So that way we will be using for signaling. So for that also there is a connection. Whereas coming to hydraulics, P pressure port, P is given as pressure port. The first three letters A, B, and C are given for working ports, and exhaust R, S, and T are given for exhaust or drain. And in hydraulics, there may be chances of leakage line, so they had given as L. And the last letters X, Y, and Z are given for control lines or pilot ports. So here you can see in the animation, we can see how a 5 by 2 works. So let us assume I am giving air pressure at 1. Initially, in one position, air flows from 1 to 2 in normal position. Air flows from 1 to 2, and whenever there is activation from one of the side, it changes and air flows from 1 to 4. And if you see, when air is flowing from 1 to 2, 4 and 5 are connected. And if air is flowing from 1 to 4, 2 and 3 are connected. In that way, whatever the extra air which is available inside the cylinder, that would be going out. So here, as I said, piloted, no, here we would be having extra ports so that we can send external source of air. These are activated with the help of air pressure. These are activated with the help of air pressure. So this is about 5 by 2 valve. Now let us see how this will we will be connecting to our double acting cylinder. For these, we have taken a double acting cylinder, a 5 by 2 direction control valve, and as usually we needed FRL unit and compressed air source. So what we do, from compressed air source to FRL unit, we will be connecting from FRL to 5 by 2 valve, and from 5 by 2 valve to cylinder. We can swap the connections also. Whenever I press the push button, air flows from 4, cylinder will be in backward. Whenever I release, air flows from 2, cylinder moves forward. So when it is moving forward, what happens? Whatever the air present in this, it goes from 4 to 5. When it is moving backwards, it goes from 2 to 3. So this is how the 5 by 2 wall works. And next we have activation methods for our direction control valves. In this, we have different types. We have general push buttons, levers, lever with detent. So, lever with detent, in the sense, these levers you might have seen our joysticks. So these joysticks, they will be returning backwards, but this lever with the detenter, they will be holding at positions. And we have foot pedals. So depending upon the size of the component, if they are smaller components, we use push buttons. If it is a bigger component, we go for levers. If it is more bigger component, we would be going for foot pedals. So that depending upon the component size, the pressure is difficult to handle. So for that purpose, we will be using different pressure applications or manual pressure. These all are manual. Okay. Nowadays we are using all our electrically signal. That is the other case. Next one we have mechanical. So for stem, we have stem activated, roller actuation in one direction, and springs for automatic return purpose. So roller activated, in the sense, whenever something touches this, this will activate. And this is in the sense, whenever something touches in the this direction, it will activate. Whenever this is touching, coming and touching in this direction, it won't activate. So whatever the lever, it will get lowered down. And springs for automatic return purpose. And as we seen, pneumatic, we will be having a slot for sending the air supply, and we have solenoids, single solenoid and double solenoids. Depending upon the type of actuation, we can go. In recent times or in recent days, we can see mostly solenoid operated valves only, mostly. So this is about direction control valves. So we have 3 by 2s, 4 by 2s, 5 by 2s. 4 by 2s are most commonly used in hydraulics. 5 by 2s are most commonly used in pneumatics. And depending on the type, we use 4 by 3s or 5 by 3s also. So thank you guys. Thank you for watching my video. Please don't forget to like, share, and subscribe to Automation is Future. Thank you guys.